In the previous lesson, we established that we have an input which is a molecule and an output which is a property, and the machine learning model is one that takes the input of molecule and gives us the property as the output. But deciding what the machine learning model should be needs two criteria to be taken into account. One is learning and the other one is the goal. The goal is more focused on the output, and if the output is discrete, just like class 1 of 4, class 2, class 3, something that's active, inactive, those types of output would be classification problems, and something like HOMO or LUMO or energy, which is a continuous output, will be a regression problem. So the model needs to be either regression type or classification type. All the exercises that we'll do in the course will be on regression, but there will be some exercises for you to do which will be on classification problems. Once we know what the output is, it's easy to say whether it's classification or regression. But what if we don't have an output at all? And if we don't have an output at all, if we just have molecules and we want to group them together by some means, that is called unsupervised learning. And an example of that is PCA, which is principal component analysis, or clustering, in which we do not have an output. But in this course, we'll focus only on supervised learning, where we have the outputs which are either HOMO, LUMO, or molecular properties or classes, and we'll use regression, support vector machines, and artificial neural networks for these type of applications. So now that we know what type of learning to use and what the goal is, we can then select a model. And models could be classical models like support vector machines or decision trees. Support vector machine tries to find a hyperplane in a higher dimension. For example, if we have a two-dimensional data, it'll try to find a hyperplane in three-dimensional data so that it could separate something like active or inactive. In case of a decision tree, it's just a decision-making tree where you put in some values of energy and the algorithm decides where to cut it off based on the labels that you have and say whether it's active or inactive. If it's inactive, it just stops there. If it thinks it's active, it looks into further energies like HOMO and then LUMO and decides what cutoffs to set to make the decisions given an input. These are classical machine learning models. We'll spend some time on these, and most of the focus for this course is on artificial neural networks. We'll talk about them in greater details later in the course. I did mention that we are trying to find a function given A's and B's earlier, which we had try to find W1s and W2s so that they map to the output. But in this case, if you look at the problem at hand, we have a molecule. And how do we represent molecules as A's or B's, a set of A's and B's, or something like that to get us an output? And that's something we'll discuss in the upcoming lectures. I hope to see you back soon.